Hi everyone, I'm James Shanim Rapirap, and in this video, I'm going to show you the lesson 10 of stress, which is working stress. But before we proceed, we define first what is stress. Stress. Stress is a physical quantity that expresses the internal forces that neighboring particles of a continuous material exert on each other, while strain is the measure of the deformation of the material. And this is our main topic, working stress. Working stress is defined as the actual stress of a material under a given loading. The maximum safe stress that a material can carry is termed as the allowable stress. The allowable stress should be limited to values not exceeding the proportional limit. However, since the proportional limit is difficult to determine accurately, the allowable stress is taken as either the yield point or maximum strength divided by a factor safety. Maximum allowable load. The load to where a member or material can carry below its ultimate load. Allowable stress. Stress that is subjected to member and material being applied with the allowable load. Factor safety. The ratio of ultimate load must be greater than 1. And here's a given problem related on working stress. A steel loop ABCD of length 1.2 meters and of 10 mm diameter is placed as shown around a 24 mm diameter aluminum rod, AC cables BE and DF. Each of 12 mm diameter is used to apply the load Q, knowing that the ultimate strength of the steel used for the loop and the cable is 40 MPa, and that the ultimate strength of the aluminum used for the rod is 260 MPa. Determine the largest load Q that can be applied if an overall factor of safety of 3 is desired. And here's the free body diagram of the given problem. Here's the given of the problem. Steel loop ABCD has length of 1.2 meters, the diameter is 10 millimeters, the cables BE and DF are used to apply Q. Ultimate strength of steel for loop and cables is 480 MPa. Ultimate strength of aluminum used for the rod is 260 MPa. And here's the assumptions. Assuming symmetry, utilize the method of joints. Joint B. F sub AB is equal to F sub BC. 2. The quantity of 3 over 5 F sub AB minus Q is equal to 0. Q is equal to 6 over 5 F sub AB to F sub AB is equal to 5 over 6 Q. For joint A, F sub AB is equal to F sub AD. 2 times 4 over 5 F sub AB minus F sub AC is equal to 0. 8 over 5 times 5 over 6 Q minus F sub AC is equal to 0. 4 over 3 Q is equal to F sub AC, or Q is equal to 3 over 4 F sub AC. Normal stress is equal to PA from P over A from book. However, in this case, normal stress is equal to Q over A, or normal stress A is equal to Q. And now, we are going to solve for cable BE. Q prime is equal to normal stress A is equal to pi normal stress D squared over 4. Now, we are going to substitute normal stress and D. Pi times the quantity of 480 times 10 to the power of 6 times to the quantity of 0.012 squared over 4. The answer is 54,286.72 newtons. And next, we are going to solve for steel loop. Q double prime is equal to the quantity of 6 over 5 F sub AB. Next is 6 over 5 normal stress A. And next is 6 pi normal stress D squared over 5 times 4. Now we are going to substitute. 6 pi times the quantity of 480 times 10 to the power of 6 times the quantity of 0.010 squared over 5 times 4. The answer is 45,238.93 newtons. And now, we are going to solve for rod AC. Q triple prime is equal to the quantity of 3 over 4 F sub A C is equal to 3 over 4 normal stress A. Next is 3 pi normal stress D squared over 4 times 4. And now we are going to substitute. 3 pi times the quantity of 260.10 to the power of 6 times the quantity of 0.024 squared over 4 times 4. The answer is 88,215.92 newtons. And now, the smallest Q will be the one with the largest load. And the smallest Q is the Q double prime, which is 45,238.93 newtons. Now we are going to solve for it. Q is equal to Q double prime over factor safety. 45,238.93 newtons divided by 3 is equal to 15,079.64 newtons or 15 kilonewtons. So, the largest that can be applied if the overall factor of safety is 3 is 15 kilonewtons. And that's all. Thank you. Thank you.